Hey everybody, how you doing? It's Coach Scott here with another edition of Coach Scott's Chemistry. Here we're going to be looking at Worksheet 4E combustion analysis. A lot of you guys were asking, how do I do this? You want me to turn this in tomorrow? What's up? So anyway, let's go on. We're going to work on some of these so we can see where we're at. So combustion analysis. Here's the secret with that, all right? When you burn something, it's organic. You burn it in oxygen, it's going to form two products. It's going to form CO2 and it's going to form water. Might throw some other things, but the carbon is going to go into CO2. The hydrogen is going to go into the H2O. Now the oxygen is burned in air, so I can't really do that. Another thing, mole concept, right? The only source for the the only source for the carbon is, for the CO2 is the carbon from the compound you're burning. So when we do that, we can use that to find the number of moles of carbon that's in the compound. So let's look at this problem here. It says we have a compound, 0.62 grams of a compound that only has carbon, hydrogen, and oxygen. So if it's carbon, hydrogen, and oxygen, okay, I can find the number of moles of carbon. I can find the number of moles of hydrogen, right? Oxygen, I'm going to have to take those moles for the compound, right? Convert those into grams, so subtract it from the total, and that'll give me the grams of oxygen that's a part of that compound. We'll work through it and we'll see it. So as this sample was burned completely in oxygen, 0.88 grams of carbon dioxide was formed, and also 0.54 grams of water were produced. So as first, what is the empirical formula? So I know I've got carbon, hydrogen, and oxygen. Okay, so first of all, let's have us, we don't even need a balanced reaction. I know I got 0.88 grams of carbon dioxide. And first we're going to convert that into moles. And how I'm going to do that is I'm going to find the gram molecular weight, molar mass, whatever you want to call it. So we're going to use our periodic table. Carbon, there's one carbon, all right, and two oxygens. Look on a periodic table, it's 12, you can see that, 12.011, one of those, times 2 times 16, that's a plus 2 times 16, and we should get 44.011, and we do, 44.011. So we have 44.011 grams of carbon dioxide and 1 mole of carbon dioxide. And if I take that, divide 0.88 grams, okay, cancel out those units, divide it by 44.011, that's going to give me the number of moles, which is 0.0199, and really 0.2 moles of carbon dioxide. So if I've got 0.02 moles of carbon dioxide, what that tells me is that I've got 0.02 moles of carbon, because there's 1 mole in each mole of carbon in each mole of carbon dioxide. So over here I can write that down. Carbon equals 0.02 moles. Okay, next, what else do they tell us here? Let's see if I can move this down a little bit, the camera. All right, let's see if I can move that down a little bit. Oh, there we go. So it says we have what? 0.54 grams of water. 54 grams of water. All right, and we have to multiply that, or divide that by the molar mass to get the moles of H2O. And if we divide the molar mass of water would be 1.0079 times 2, because there's H2O, and hydrogen has a mass of 1.0079, plus 16, which is the molecular or the atomic mass of oxygen. So that gives us a grand total of 18.0158. 0.158 grams of water. So if I take 0.54 divided by 18.0158, that's going to give me 0.03. Now notice, for every mole of water there are 2 moles of hydrogen. So I'm going to take that and multiply it times 2 because I have 2 moles of water. And if I look, I've got 0.06. 0.06 moles of hydrogen. So my hydrogen equals 0.06 moles. Okay, so I can actually write that down there. So I'm going to go 0.02, 0.06. I still need to know the number of oxygens, right? So how do I do that? Now I know the moles of carbon, I know the moles of hydrogen, so I can take those moles that I got of that compound, and now I can do some more conversions, and I can convert those, all right, into grams. So again, I have 0.02 moles of carbon, all right, and if I do my atomic mass, I multiply it by the atomic mass of carbon, which is 12.011, I'm going to get grams of carbon. 0.02, oops, times 12.011. All right, and if I hit that, it's going to give me 0.240 grams. 0.240 grams of carbon. All right, my hydrogen, I had 0.06 moles in the compound, 0.06 moles of oxygen, hydrogen. All right, if I multiply that times the atomic mass of hydrogen, which is 1.0079, that's going to give me a grand total. All right, let's clear that out. 0.06 times 1.0079, and that's going to equal 0.060 grams of hydrogen. So if I sum these grams up, right, 2, 4, my fault, or I get 0.300 grams of oxygen, or of carbon hydrogen, right? 0.300 grams. So if I take that number and I go all the way up here, 0.300, and I subtract that from 0.62, the total mass of the compound, I get 0.3195 grams. 0.312 grams of oxygen. So now, if I take that number, and we'll go down here just to have more room, I take that number, 0.312 grams of oxygen, and I'm going to divide that through by the molar mass, or the atomic mass of oxygen per mole, all right, divided by 16, I'm going to get moles of 0.02 moles. 0.02 moles of oxygen. So if I go back up here, I've got 0.02 moles of carbon. I've got 0.06 of hydrogen and 0.02 moles of carbon, or of oxygen. So if I divide through to make these whole numbers, I divide that through by the smallest one, which is 0.02, like so, then I'm going to end up with carbon 0.02 divided by itself is 1. Hydrogen 0.06 divided by 0.02, I'm going to get 3. Oxygen, I'm going to get 1. So the empirical formula is CH3O. I'm going to box my answer in. Okay? Now, to get the molecular formula, the second part of this problem, the molecular mass is 62.1. So I found my empirical formula, so I need to get the atomic mass of the empirical formula. So I'm just going to total everything up, 12.001 plus 3 times 1.0079, right, plus 16, or 1 times 16 for the amount of oxygen, and I get 31.0 grams, the empirical formula. Okay, 31.0 grams empirical formula. Notice up here it said that the molecular formula is 62. So now if I take 62.1 and divide it by 31, I get 2. So I'm going to use a factor of 2 to get the molecular formula, multiply that through by everything, so I get C2H6O2. So that would be the molecular formula, because I took the molecular weight, divided it by the empirical weight, and I see that it is a factor of 2. Problem solved. Hopefully that helps you with combustion analysis. I'll look at problem 2. Again, you don't have to really do that one as bad.